We'll continue with chapter 8, trigonometry. Prove the following given identities. Question number 28. We have cos theta, cosec theta, sin theta, sec theta by cos theta plus sin theta. We have to prove that it is cosec theta minus sec theta. We have a mix up of so many ratios. So what to do? Let's change everything to sine and cos. Then after that, we will see what we can do next. Cos theta already cos, leave it. Cosec, we know it is 1 by sine theta. Then minus sine, let it be. Cosec sec theta, we can change it from identity 1 by cos. Then numerator, since denominator, we have cos and sine, let it be there. Then here now we can see cos by sine, here sine by cos. So let's take LCM since we have fraction now. Sine and cos, they are different, so both will be LCM. Sine divide the LCM, we are left with cos. So cos into cos will be cos square theta. Cos square theta into 1, cos square theta. We have minus cos theta divide here, we are left with sine. So sine into sine will be sine square theta. So now these two, sine theta, cos theta, we can take them along with the denominator. Then now here we have a square minus b square. So we can apply the formula a minus b, a plus b. Then in that case, the positive part will be cancelled here. We are left with cos theta minus sin theta by sin theta cos theta. If we check the right hand side, we want cosec minus sec theta. So again, let's break the LCM. So we can write cos theta by sin theta cos theta, sin theta by sin theta cos theta. Sin theta cancel. 1 by cos equals sec theta. Cos by cos cancel. 1 by sin cosec theta, which is equal to right hand side. Then we go to 29. We have cot theta, sec theta minus 1 by 1 plus sin theta. In the right hand side, we want sec square, 1 minus sin, 1 plus sec theta. Here we have 1 plus sin in the denominator. Here we have 1 minus sin in the numerator. Then here we have sec theta minus 1 in the numerator. 1 plus sec theta in the denominator, opposite. So what to do? We have to rationalize, to rationalize at the same time. We rationalize the denominator as well as the numerator because we get the opposite sign with same ratio. So we have to do that. 1 plus sign, if we rationalize it, we have to multiply with minus. So if we multiply minus in the denominator, we also have to take it in the numerator. The same way for sec theta minus 1, we have minus. To rationalize it, we have to do it plus. So if we rationalize in the numerator, we have also to put it in the denominator. Then after that, here we can apply now. A minus 1, a plus 1, it will be a square minus 1. Then this one, we write it as it is. In the denominator, again, we have 1 plus sine, 1 minus sine. We can apply formula a plus b, a minus b, which is a square minus b square. Then now, if we check from identity, sec square minus 1, it is tan square theta. We can replace. Then 1 minus sine square theta from identity cos square theta. The rest we can leave it as it is first. Then now cot, we know it is 1 by tan, so we can replace. So we have tan square up, tan square down, we can cancel. Then in the right hand side, we want sec square theta. So 1 by cos square theta equals sec square theta. We have 1 plus minus sine, then down sec theta plus 1. If we check the right hand side, that is the right hand side we want. Okay, so that means we prove. Then next we will go to number 30. Here we have sine cos, there also cos sine, but in the right hand side we want only 0, there is plus sign. So what shall we do? Since we have ratio, we will take the LCM. So look at the denominator, both are different. So we have to take both as LCM, okay? Then if we take this one, divide LCM, we are left with sine A plus sine B. Here we have minus, but the one we have to multiply plus, so we have to write them both. Then here also, if check this one with LCM, This part will be cancelled. We are left with cos A plus cos B. If we check here, this is minus, the one we have here plus. We have to multiply them. So let's write them both. Then now here we get A minus B, A plus B. So it comes formula A square minus B square. There we have A minus B, A plus B. We have A square minus B square. Okay, so in the denominator we cannot do anything, let it be there. Then now in the right hand side we want 0. So what to do? Sine and cos, they have relation using identity. So no need to change both, we can change one. Either you change sine or cos, that is up to you. But I feel better to change cos, okay? You can change sine also, it's okay. Then leave the first part. Then the second part we can apply identity. Cos square A, we can use identity 1 minus sine square A. Cos square B also same, we can use 1 minus sine square B. So let's multiply, remove the bracket first. Denominator, leave it as it is. The first part also write it as it is. Remove the bracket, plus 1 plus 2 minus sine square A. Here minus 2 plus minus 2 minus plus. Then now here we see plus 1 minus 1 will get cancelled. Sine square A, sine square A. 1 plus 1 minus. So they will get cancelled. Sine square B, sine square B. 1 plus 1 minus. Everything get cancelled, becomes 0. So 0 divided by whole new denominator will become 0, which is equal to right hand side. Then, okay, 31 we'll do later on. Let's see number 32 first. Here we have 1 plus 1 by tan square A, 1 plus 1 by cot square A. We want 1 by sine square A minus sine 4A. We have to convert everything to sine and cos. We know the relation. 1 by tan square A equal to sec square A. 1 by cot square A equal to cot square A. From identity, 1 plus cot square A, it is equal to cos x square A. 1 plus tan square A, we know it is equal to sec square A. But we want sine in the right hand side. So cosec we can make it 1 by sine square A. Sec we can make from the relation 1 by cos square A. In the right hand side we want only sine, we don't want cos. So since it is cos square, we can convert it using identity. So from identity we get it is equal to 1 minus sine square A. So sine square A into 1 sine square A. Then we have minus sine square A, 2 into 2 will become 4, which is equal to right hand side.